All right. Hello, welcome everybody to the presentation of our short paper with the title Building Hybrid DApps Using Blockchain Tactics, the Meta Transaction Example. My name is Florian Blum and I'm a PhD student from the University of Duisburg-Essen in Germany, and I will first tell you a bit about my area of research. So let's start with the motivation. We want to use blockchain technology in our application because we want to take advantage of blockchain technology itself. So we want to use this decentralized, trustless, transparent, and tamper-proof app environment. But we also have to deal with the disadvantages here. We have a transaction cost, we have a delay due to block creation time, there's technical complexity, and updates are also difficult. What also is challenging to determine which attributes are important for my use case and which elements of my architecture would benefit from using blockchain technology. So what we see is an increasing need to build good decentralized or DApp architectures. And what we need are best practices, architectural patterns, and design patterns for smart contracts. What also is missing currently are concepts to support our architectural design of blockchain-based applications. And because my impression is that building blockchain-based applications is somehow different from common software or current approaches are not sufficient for that, that's exactly my area of research, how to support the architectural design of blockchain-based applications. When discussing with researchers and people from industry, it seems to make sense to combine the best of both worlds. So as a first step towards adoption of blockchain technology, this means adding a small component or replacing an existing element in your system, which led to the idea of hybrid software architectures and was developed over time. Hybrid software architectures capture the idea to balance between centralized and decentralized elements. It shouldn't be confused with hybrid blockchains. So the question is, how do we add blockchain technology to an existing system? And how can we replace an existing component with a decentralized counterpart? In general, you could say blockchain technology is still new in software engineering, and the impact of design decisions on security, maintainability, performance, or cost is still unknown. So we need a new blockchain-oriented view in this case. So we propose, therefore, blockchain tactics as a guideline and a structured way for changing or building a system. This led to the whole idea of blockchain-oriented software engineering. So how do we build hybrid software architectures, achieving a good balance between centralized and decentralized elements? All our ideas are captured under the title Hydra Engineering Process and consists of two parts. It stands for Hybrid DApp Requirements and Architecture Process. So the two parts are, on the one hand, we have the Hydra engineering process itself, which somehow captures a modified requirements and architectural engineering process, and it tells you about the collection of certain information and the focus on data flows, value flows, and trust relation between the actors in the system. And on the other hand, we have blockchain tactics, which are the focus of this paper. So what are blockchain tactics and how do they come from? They are inspired by the architectural tactics by Len Bass and describe the relation between a stimulus and a response. This means a tactic is a design decision that influences the control of a quality attribute response. This means it describes the impact of an architectural decision on a certain quality attribute. For example, in this case, there are modifiability tactics, and the stimulus here are the input arrow, the change request, and the response that is required here afterwards is that the changes are made and deployed. And in between there are the modifiability tactics, which cover an overview of how to achieve that. And we adapted this idea for blockchain-oriented software engineering and try to capture best practices to deal with those challenges in between, because we like this idea that gives the ideal level of abstraction here for a hybrid approach. It's not too coarse, not too detailed, so this fits to our idea here. So these are the blockchain tactics and the figure from our paper. So the terminology of strategies, tactics, and design patterns is common in the area of architectural tactics, and we adapted these for the blockchain-oriented software engineering. In this figure, we show a few examples what can be defined as a strategy or tactic or design pattern. So in general, the idea is not restricted to blockchain. As you can see, there's the strategy reduced centrality on the top, which can also be achieved by using a distributed database with other advantages or disadvantages, of course. But we focus here on the tactic to use blockchain technology. the figure highlights the relation between those elements. This means, for example, a possible stimulus for a tactic is written here, and which sub-tactics exist, which design patterns support implementing the tactic, etc. So the idea is to balance the overarching strategy with the result of certain tactic and design pattern choices. For example, we want to support the strategy increased transparency, then you can follow the tactic, use blockchain. Then you need to consider the possible impact on privacy by using the sub-tactic accommodate privacy. Then you can see the sub-tactics that support privacy, such as off-chain computation. And finally, which design patterns help to implement this. So this is the overview and how these strategies, tactics, and design patterns are related. To understand this better, let's take a look at an example. So we want to understand how to use these blockchain tactics and the actual usage for selecting tactic and eventually find a design pattern. What you also want to do here is to understand and acknowledge the trade-offs for each step we have here. So what we actually do is we follow a certain path in the overview figure of the blockchain tactics and discuss trade-offs for every decision. So first we start with the requirements. We assume we gathered the requirements by using the Hydra engineering process before. We have several process diagrams, we have data flow diagrams, etc. And this is where we start with before selecting those tactics. We start on top with the strategy, and the basic or the most important goal we want to achieve here is to reduce centrality. So this was the general idea we follow here. And then we take a next step and take a look at the tactic that supports in this strategy, and this means using blockchain technology in our case. So we immediately have here the pros and cons of that. So by using the tactic blockchain technology, we have the pro of having a tamper-proof and transparent environment, but also the disadvantage that having a low user experience as sending a transaction requires a fee. So this is for this selection of a tactic, immediately the pros and cons we have here. When we follow this path in this tree, we can see on this graph, we can see that the disadvantages of using blockchain technology can be accommodated by following this tactic to accommodate the user experience. And when we take a look what design pattern is connected there, there's a meta transaction design pattern that helps to accommodate UX, so to deal with the disadvantages we have by introducing blockchain technology into our system. So we have this advantage here that we now have signed and tamper-proof transactions by using the meta transaction design pattern, but also the disadvantage that we have increased costs due to the higher smart contract complexity, because you have this on-chain validity check of the meta transaction, in addition, of course, to paying the gas fees. So what we end up with is an architectural design or a first architectural draft, and the resulting pros and cons we collected on our way through our graph here. So this means this draft we have here for our architectural design is a tamper-proof and transparent system which offers a good user experience but has the disadvantage of increased costs in general. So we're now able to consider several paths through our graph and compare the resulting architectural design drafts. Then we can compare the pros and cons and decide which trade-offs are acceptable for our system. This could also be accompanied with the requirements and the prioritization of quality attributes, which are specifically important for my system we are building. So this was the main idea of our short paper here. Let's take a look at the future work. What is our current state? So we propose the Hydra engineering process, which is somehow a concept that tells you which information to collect and how to use it when building blockchain-based applications. What's important here that we want to create awareness that careful planning of the architecture is even more important for a blockchain system, and that the architectural and design patterns can have a strong impact on quality attributes, and then that you need to be aware what are these impacts and how they are impacting the quality attributes. So we propose these architectural tactics or these blockchain tactics as a first means to somehow capture or combine these information and put them together in a clear model. Our next steps here are to apply those tactics in more real-world scenarios or research projects we're currently working on, to learn from them and refine them, create new ones, put them into this graph, and build specific guidelines for selecting design patterns. So guiding people through this network of strategies, tactics, and design patterns, and helping them to how to select those. And we want to evaluate guidelines in research projects. So the future could be that you have a collection of those tactics and wrap them together in what is called an architectural strategy. So this could be somehow captured under the umbrella of something like towards a blockchain architectural strategy would be probably the title of a future paper here. So this is our idea, and this hopefully captures what we want to tell you about blockchain tactics and give you this awareness about the impact all those design decisions have on the architectural design in the end, and what are the impact on quality attributes for your system. So thank you very much for your attention. I'm happy to answer any of your questions. Feel free to send me an email or a direct message on Twitter, and just let me know if you have any questions or feedback to that. So thanks a lot.